Well, welcome everyone, and thank you for joining us for another webinar session in the Change for Climate Lunchbox series. My name is Heather Wheelaker, and I'm here with my colleague, Karen Young. Both of us work in the Economic and Environmental Sustainability branch with the City of Edmonton. We're joined by another colleague from our same unit, Lisa Dockman, who will be delivering the content of today's session. As well, joining us is Patrick McMahon from Summerhill Consulting, who is on standby to help answer any questions that may arise during or after Lisa's presentation. Just a note that this session will be recorded, and we are only recording the speaking and the presentation slides. At this time, I wish to acknowledge that we are on the traditional land of Treaty 6 territory. We do this to create awareness and to remind ourselves that we are all treaty members, no matter where we are from or what language we speak. If you're dialing in from another territory, I encourage you to respectfully acknowledge your treaty or territory responsibilities. I did not grow up on Treaty 6 territory, but I have a strong sense of belonging because of the inclusive and respectful environment created here. This environment is something that we cannot take for granted. Instead, each of us shares responsibility for opening our hands and our hearts to be inclusive. It is now my pleasure to introduce today's presenter. Lisa Dockman is a project manager who develops and implements programs for homeowners that move us closer to reaching the goals of Edmonton's community energy transition strategy. One of the more recent programs that Lisa oversees and will touch on during this session is HERA, the Homeowner Energy Retrofit Accelerator. Here to share her knowledge about improving the energy efficiency of your home is my colleague, Lisa Dockman. Welcome, Lisa. And I can see your screen and it's in presentation mode. So thanks, Lisa. Please go ahead.
Thanks, Heather. Wonderful. Thanks, everybody, for joining us today. And thanks to my colleagues for organizing. Yes, so Lisa Dockman, I'm happy to present about home energy efficiency today. And as Heather mentioned, we work with Patrick McMahon, who is joining us from Summerhill Group, and really grateful for his technical expertise in this area as well. He'll be helping answer some questions as I go, so feel free to ask them anytime or after the presentation here. Let me just, okay. So many of you may be familiar already, but for those that may not be, this work and what I'll be sharing today is part of Edmonton's Community Energy Transition Strategy. So this is a strategy that was unanimously approved by Council in 2015, and it's really a roadmap of how to get Edmonton to a low carbon, sustainable energy future and how to really take advantage of the opportunities and this transition that's happening all around us. So it has a number of targets and then actions to achieve them. And the targets here are around greenhouse gas emissions reductions, saving energy, and then also generation of electricity locally. So as this program or as this strategy has been implemented since 2015, you'll have heard of, hopefully, and seen pop up programs and initiatives that are working to target each of the sectors, each of the ways in which Edmontonians consume energy. So you'll see commercial buildings industry are contributors of energy consumption in Edmonton. So for example, we have programs like the Building Energy Benchmarking Program or the Building Energy Retrofit Accelerator that are working to achieve our outcomes in those areas. Also, a significant part of our energy use is in transportation. So we have colleagues who are focusing on how do we decarbonize or significantly reduce those emissions through things like, for example, electric vehicle charger infrastructure and those kinds of things. So those are, again, for other days. I'm going to be focusing on this 19% energy use in residential buildings. So that 2015 strategy is nearly done being updated. An updated version of it was requested by council in 2019, at actually the same time that they declared a climate emergency. So City Council has been very ambitious around their carbon goals. They've signed on to something called the Edmonton Agreement, which is a commitment to align our action with that of the Paris Agreement target to keep the global average temperature increase below a 1.5 degrees Celsius. So that is the recommendation, the 1.5 degrees of the scientists that work with the IPCC, or the Intergovernmental Panel on Climate Change. And it's their recommendation in order for the world to really avoid the most dramatic or catastrophic impacts of climate change. So I just wanted to share that we're very excited that after 2 years almost, that this work is going to council on April 12th to Executive Committee of Council. The report is actually available publicly online right now. We can if maybe Karen or Heather could share the link, that would be great. Do encourage you to read it, provide your advice to council as they make this decision, and you of course can register to speak at that as well if you'd like. So just one more piece of strategic context before I get started is really the energy transition strategy is aligned and sort of captured as well in the city plan. So our new city plan was approved just in late 2020, and it's really the roadmap for Edmonton to grow to a city of an estimated 2 million people. So what are the big city moves that are important to this community as we grow? And one of them is really this idea of greener. So there's these 3 targets in the Greener as We Grow Big City Move around urban trees, but also around a community-wide carbon budget and a net per person GHG emission of 0. I believe this is by 2050. So these are very ambitious goals, and the updated strategy is working as sort of the roadmap of how we would achieve these goals and targets. And of course, as you've seen, the residential sector is a really important one. 20% of our energy use needs to be a part of that solution. So then maybe just one more thing before we move into kind of some of the actions and some of the things that residents of Edmontonians can do is really just talking about, that community energy transition strategy is our mitigation plan. So this is our community plan to reduce greenhouse gas emissions that are causing climate change. And there's lots of actions and ways that we can mitigate our impact. But there's also the other side of this coin, which is adaptation. So these are actions that manage the risks of an already changing climate. And so both of these kinds of actions are important on a community level, but also in your home. And I'm going to be focusing more on the mitigation ones today, but I did want to give a couple examples. And then I wanted to point out that this Climate Resilient Edmonton Adaptation Strategy and Action Plan is Edmonton's approved strategy for kind of at a community level, how we can adapt to an already changing climate. So that's an important distinction there. And then, I mean, more so in your home, the kinds of household climate actions that you can take. I mean, some of these mitigation ones will, stand out because they're saving energy. For example, adaptation ones that I might point out is things like backup battery power. They're going to have that resilience in the face of emergencies, for example. Flood and fire protection, lots of things you can do to your home to be more resilient in those instances. And then a couple of things that actually work to achieve both. So a good example would be water conservation. So not only does that save the energy associated with heating that water, which is a mitigation action, but also our climate projections show that as the climate changes here in Edmonton, we're likely to have more frequent and severe droughts. And so as water becomes less available, that water conservation is a really important action. So what are the kinds of things that you can do to improve your home energy efficiency? So we think it's important to start off there are just so many things that you could do to improve your efficiency at home. And I'm sure a lot of us have heard about many of them. What I like to start with is thinking about your greatest users of energy in your home. So I think grounding the conversation in the fact that, the average home energy use, more than 60% in the average home is from your furnace. So generally a furnace from space heating. So this is by and large the lion's share of that energy consumption, and it can kind of help determine how you might make the greatest impact from your household decisions. Of course, appliances and water heating are also really significant here, and there's actions related to those as well. But just a note. I also wanted to mention, if you want to take a deep dive into any of the kind of things, energy systems in your home, the kinds of actions or equipment you can adopt, what all the technical language is around the different, efficiencies or certifications or factors for windows or equipment efficiencies or whatever it may be. There's tons of details in these change for climate guides. So the homes one is a little bit more tailored to homeowners. The habit's a little bit more tailored to maybe renters. So please encourage you to check that out. And then also climateresilienthome.ca. I actually believe my colleague Heather was the one to work on this, but it's a really great resource as well on more of those adaptation actions that you might be able to take in your home to make it more resilient. So lots and lots of tips there. Now, the kinds of actions you can take, I also feel that this spectrum of actions from the Change for Climate initiative is a really great example too. So, we've put this together and to demonstrate the kind of breadth of actions you might take to save energy and reduce your carbon footprint in your home. So for example, I just thought I might mention something I love about this is that the actions are actually coded and then color coded to demonstrate their relative impact. So those like with a 1 are those that have sort of the least impact on your carbon footprint, whereas those with a 5 that are darkest at the bottom have the greatest impact. So I think just like something to consider as you're looking at where to focus your time and energy. Drying your clothes naturally is a great example of not having to use an electric clothes dryer. Using a toaster oven for small meals, saves energy from not having to heat as much space or be as energy intensive, for example, as your oven. Driving an electric vehicle. I mentioned that we have some programs and initiatives around this action, but an interesting thing I like to share is that we know through research that while Alberta has quite a carbon intensive grid, electric vehicles are just so much more efficient than a traditional or internal combustion engine. I'll say ICE, but an ICE engine that even today in our carbon intensive grid, there is carbon savings from driving an electric vehicle. And actually that's only set to increase over the life or the ownership of that vehicle. Because as the grid's greening, and that is something that's happening actually even faster than folks anticipated in Alberta. Wall insulation is a significant one too. We'll talk more about that in a bit. Working and playing close to where you live. So this one's a really straightforward way of reducing your transportation related emissions is by being really intentional about where you choose to live, and then because that has all those impacts on your carbon footprint. And then another sort of, level 5 or one of the greatest impacts would be investing in renewable energy with a solar photovoltaic system as an example, which again, we'll get into later. So we know that the Paris Agreement and these 1.5 degree targets are very ambitious, and significant improvements are needed to the majority of the homes and buildings that exist today. And there's also lots of other things that are needed in other sectors and, for example, for new homes and buildings. But some of our research is showing that something on the order of a 50% increase in energy savings is needed through the renovating of existing homes. So really that is a much larger and more significant renovation than I think many people undertake for their home. And that's, not to be underestimated. It's a significant time and financial investment. But we did think we would spend a bit of the time today talking about this idea of renovating to net zero. And it doesn't have to happen all at once, but like what might that pathway be for your home? And let's share a bit of information and chat about that. So when I say net zero, I mean a home that produces enough renewable energy to meet the home's needs on an annual basis. So on any given day, it might be drawing from the grid, for example, but really that kind of net is zero over the course of a year. Now, luckily, Edmonton has been referred to as the net zero capital of Canada. There is quite an industry and a lot of activity around renovating and building net zero homes in Edmonton, over a couple hundred at least, from what I've heard. And that's because there really are a lot of benefits. People are, tend to get really excited about when they learn the potential for their homes. And some of those benefits include dramatically reducing your carbon footprint, um, often having a lower total cost of ownership. So when you consider not just the cost of those renovations immediately, but the energy savings, the utility savings, the savings from repairs and maintenance over the lifetime of that home, oftentimes we're starting to see that it is a good financial decision. More comfortable, quiet, and improved air quality in these homes. So all you have to do is meet somebody who owns a net zero home, and they are, very excited, enthusiastic about how comfortable, quiet they are. And then we know with mechanical ventilation that's necessary in these homes that there's also a excellent air quality. And then lastly, higher market and resale value. So really energy efficiency is something that buyers are looking for. There's lots of evidence of that. And so this does help improve, does sort of add value to that asset. And then I just provided an example here. So this is a photos provided before, during, and after a deep energy retrofit by the Renew Engineering and Butterwick. So you'll kind of see that that transformation. So really every home's going to have a different path to net zero. And that's really important. We do advise that you hire building professionals to understand what that path may be, whether or not you intend to do that work right away. But what we do know though is the kind of phases you might go through, those steps are really common and can be, are consistent throughout the majority of these projects. So I thought we would just highlight them and talk a little bit about each of those steps on that pathway to a net zero renovation. So the first kind of step or a group of steps would be to make it tight. So energy efficient homes don't let much air escape. So they're minimizing the treated air leaving your home because of all the energy it takes to treat that air. So this can be done through really great air sealing, through insulation, which I'll get to in a moment. But air sealing examples are things that minimize leaks. So really focusing on leaks around doors, windows, vents are another really good example. Eliminating chimneys is another good example of where there's can be significant air leakage. I know when I had an energy advisor in my home, I didn't realize that my very old furnace has, a 6 or 8 inch hole that is just cold air coming from outside. And so there are ways of addressing that with, more like kind of with mechanical upgrades too, like to your equipment. So this diagram does have just examples of where your home loses energy. And so a good example that you'll see, like it's really from all areas. And one way that you can evaluate your home's air tightness for this one is, and sort of the efficiency of your building envelope, is through an EnerGuide evaluation, which I'll get to in a moment, which really is looking at your air changes per hour. So how many times air is turning over within your household. And you can then use that as a comparator before and after renovations. So very connected to that is sort of the second step in renovating to net zero, and that's insulating. So obviously lots of types of insulation, but this diagram is really just trying to demonstrate that insulation to current building code, which is a national standard building code, that's developed by the federal government, is not high enough to be net zero. So I think that's important in a few ways. I mean, building code has increased in efficiency over the years. And so certainly this is higher insulation than you would see in older homes. But I think there's sometimes an assumption that new homes are automatically high performing energy efficient and maybe even close to net zero, but there is still, like if you are, for example, building a new home, you may still want to ask for the kinds of insulation that would result in net zero. And, these first two steps really are focusing on building envelope, and it is really the most important thing to consider if you are building a new home, for example, because it's so much harder to go back and get right afterwards. You can make changes to any of the equipment that's a little bit more conducive, but you really have a lot more of a significant challenge to upgrade your envelope once your home's built. So this R value here, you'll see, for example, R59, that really is just an indicator of the quality of that insulation. So the higher the R value, the better the insulation. So this is really just showing that the higher R value is needed in all of those types of insulation for a net zero home. And then the third step to renovate to net zero is sizing for the space. So homes with better insulation and improved air tightness require less space heating and smaller equipment. So this is a really important one because whether you're going for electric heat pump, for example, or a high efficiency natural gas furnace, either way, the importance in sequencing here is that if you deal with that after you looked at your air tightness and insulation, then you're going to actually choose a more appropriately sized equipment for the space. So some of you might have heard of heat pumps. So heat pumps are a lower carbon alternative to furnaces in energy efficient homes. So the way that they work is they collect, concentrate, and transfer energy from either the air or the earth to heat a home. So that would be an air source heat pump or a ground source if it was underground. And then this can be reversed in the summer to cool your home. So I think, these are a relatively new thing for homes and buildings, but the technology is not that new. It is the same kind of technology that's used to refrigerators or air conditioners, right? So if you think about a refrigerator, the pipes become really, really warm to the touch as the interior cools. And so that's an example of a heat pump in action. And essentially, this is just using that technology to replace a furnace in a home or become the primary source of space heating in a home. So this last point here is heat pumps can deliver 3 or more times the amount of useful energy compared to the energy they consume, making them significantly more efficient than a combustion heating appliance like a natural gas furnace. So this one's a really important one because we're really seeing a rapid transition in a lot of communities, maybe less so in Alberta, but buildings and homes are being renovated and built with heat pumps across the globe. It's becoming more and more common. And part of the reason is that you're looking at things like air source heat pumps being like 300 to 350% efficient as examples, ground source 500% efficient, whereas a furnace 95 to 97% efficient. It's just a different order of magnitude. And then the last step to renovating to net zero is generating energy. So now that you have a highly efficient, airtight home that's been, has electrified, could have like electrified heating and cooling systems, for example, you then can combine that with a rooftop solar panel installation to generate enough green electricity to meet your needs. So here's a photo of Queen Elizabeth Outdoor Pool. You'll notice it has solar voltaic panels there that are kind of on a flatter angle. And then you'll also notice a solar thermal installation. So that one's a little bit different. Those are a little less common in homes. But really that rooftop solar kind of functions as you can see in the diagram here. So the modules that are, collecting the sun's energy to transfer it into electricity and then to use that in the home, invert it, use it in the home. And then if there's any excess, because these systems are generally grid connected, then that is fed back into the grid through a bi-directional meter. And then the last thing to mention around renovating to net zero is really this idea of sequencing. So every home is different. And again, we strongly recommend hiring a building professional to understand your home's pathway, whether or not you plan on doing all that work immediately or whatever your plans may be. But really, the reason for that is that it can help ensure that your current and future renovations are complementary to one another and aligned with that pathway. Because unfortunately, even minor renovations that may seem aesthetic or that, like maybe they may actually be limiting your ability to achieve a net zero home in the future because you're investing in ways that aren't compatible with that. So a good example might be new basement flooring that limits your ability to get insulation in the future. Furnace replacement, for example, if maybe you needed a smaller one after upgrading your envelope. Or another one might be even the exterior. I live in a 1953 home and have pretty old exterior to my house. And if I was to replace that without considering, for example, if external insulation might be a good idea, then that's a really kind of a lost opportunity. So when is the right time to explore your home's pathway to net zero? The sooner the better. Now, I did want to share a little bit about two programs that we currently have available for Edmontonians to encourage this sort of them on their pathway to reducing their carbon footprint and generating renewable electricity. So that's the Home Energy Retrofit Accelerator and the Residential Solar Rebate Program. So what is HERA? It's a residential energy efficiency incentive program designed to facilitate home renovations that reduce carbon emissions, save energy, and support local renovation businesses. So we know that homeowners make decisions to renovate sort of uh, all the time for all kinds of reasons, growing your family or maybe aesthetics or functionality of a space. And really this program is trying to integrate energy efficiency into that decision making and then ultimately also support an intensely local industry, which is planning and implementing renovations. So really well timed with some of the COVID recovery efforts in place. So HERA provides rebates for things like insulation, windows, water and space heating equipment, both furnaces, and so both sort of traditional things like furnaces or natural gas tanked heaters, and maybe newer ones like air source heat pumps or tankless water heaters. And then there's bonuses available for more significant retrofit projects. So really this program is hoping that over the course of 18 months, participants will undergo multiple upgrades, and then there's a 20% bonus for homeowners that do 3 or more upgrades in that period. So we're looking at making energy efficiency more accessible to a larger group of Edmontonians, to maximize the greenhouse gas emissions reductions through those retrofits, to advance the retrofit economy. And then the last one here is to stimulate the market to properly value energy efficient homes by making household energy performance information available publicly. So this is really important in that, unfortunately, energy efficiency is relatively invisible. Most people can't tell how efficient a home is or a building by looking at it. So this is really trying to get, widely available understanding of the efficiency of homes and buildings and making that kind of transparent and public so that it can be valued. So for those who participate in HERA, the first step is to get an EnerGuide home energy evaluation, which I'll speak to in a moment. Then they use that EnerGuide label to enroll in the program through a brief online form. They then should be reviewing all of the program documentation to make sure that their plans align with what is the greatest opportunity in their home, but also with the equipment specifications of what is eligible for rebates. So really taking a good look at the program materials as to what efficiency, what standard, what documentation and whatnot, to make sure that those upgrades are compatible with our rebate criteria. But then the upgrades take place and then homeowners apply for their rebates after they've made the upgrades. And they can apply for sort of one at a time. Say, for example, they're doing 3 or 4 upgrades over the course of that 18 months. They can apply for them all at once or sort of after each one's complete. Really, either way is fine. And then see how you did. So homeowners who would like to, and it's optional for most of the measures, can get a post retrofit EnerGuide evaluation to kind of compare how their renovations performed. So this is the program website if you'd like more information. It has all of terms and conditions, as well as a program user guide and an eligible products and services list, and as well as a frequently asked questions. So some of you may be more familiar with EnerGuide or may already have one, but for those that aren't, EnerGuide is a rating system for buildings and consumer products. So you might recognize this logo here at the bottom. I think what's a little bit less well known is EnerGuide. There's also an EnerGuide for homes. So this is a tool that helps you understand how efficient your home is, how much energy does it use, and how you can improve its efficiency. So they're completed by an EnerCan certified energy advisor that involves an in-person visit of 2 to 3 hours that includes a blower door test. And then all of your household information is entered into an energy modeling software that helps you understand how your home is using energy and how it's performing as a system. So here, for example, is my EnerGuide label for the home that I live in. And then, of course, a picture of the blower door test underway. So what the blower door test does is it's measuring the air tightness of your home. And it does that by decreasing the air pressure throughout your home and creating a vacuum, and then monitors how air moves and escapes to really, understand that air tightness and sort of evaluate those air changes per hour. And then the label here, I thought what I might just point out is it's a gigajoule rating of how much energy is used in your home through a combination of natural gas, if you have it, and electricity. So 164 gigajoules a year is used in my home. And this 92 number is how much energy my home would use if my same home was built today. So keeping certain things consistent, but understanding sort of current building code. And you'll see that we're significantly more energy now than it would be if built today. And again, the furnace, space heating being a significant part of my energy footprint. More than just the label, homeowners also get a few other documents, one of which is a renovation upgrade report. So this is a screenshot of mine. And as you can see, it demonstrates that if I underwent the changes that are recommended by my energy advisor, I could expect that my gigajoule rating would be 70 gigajoules a year, which is a significant reduction from the current. And then it kind of goes into all of the steps and the associated energy benefits I could anticipate from those steps. So you'll see attic insulation, upgrading my furnace, which is a big one. In this graph here, you'll see that's the significant reduction that would have in my energy consumption, and on and on. There was actually a lot of recommendations because my house is fairly old. The energy advisor also does, uses a thermal imaging camera to understand how your home is losing energy, and really is taking a snapshot of the temperature differences in your home as to help communicate where there could be things like air leakage, or where there might be something like thermal bridging, where there's a transfer of heat because of like wall framing, for example. So I mean, again, I'm not an expert, but if you look at this image here, there's a wall socket that you can see. Wall sockets generally don't have insulation, so there's a lot of cold of energy loss there. And then I could actually feel with the pressure, with the vacuum created in my home, you could feel cold air coming in that one image at the top right. And then the one at the very bottom there, you can actually see the wood framing in the home. So a really good example of some opportunity areas in my home. And then, of course, folks that participate in HERA and get an EnerGuide label, we do ask for their consent through the terms and conditions to share their EnerGuide label. So not the supporting documents, but the label itself on our home energy map. So this is a map that we've operated since 2017 and has almost 5,000 EnerGuide labels from the region around Edmonton. So really is a way of trying to make that energy efficiency visible and trying to really drive folks to consider and value the energy efficiency of these homes. The other program I wanted to mention briefly is the residential solar rebate program. So this is, when I say solar, and again, we spoke about it already a little, but for this program, we're talking about solar photovoltaic or PV modules. And so this is electricity and not solar thermal. These are only for solar installations that are compatible with the province of Alberta's microgeneration regulation. So that has a lot of considerations, like for example, it limits the size that the system can be on your home. And then the components are like modules, racking, inverters, examples. And then it also must be grid connected so that it powers your house, but then excess, like for example, during the summer months when you're producing more than you may be using in your home, that excess flows back into the grid and becomes credits on your electricity utility bill. So the solar rebate program provides 40 cents per watt to homeowners, and it's about 15% of the cost of the total system. And then there's a couple limits as well, and then new home builders are eligible for this. There's a two-part application, so application that needs to happen before the installation, and then funds are reserved for that project should it be completed as expected, and that's in the post-install phase. Residential homes and buildings of all types are eligible for this. And, as a first step, homeowners should contact an approved solar contractor, either from the Solar Alberta or the CanREA list of contractors, because it is a requirement that the installers be from one of those lists. And then, of course, full eligibility criteria online. And then if you're kind of, considering solar and not really ready to contact a contractor, one thing you could do is check out MyHEAT. Edmonton has worked with MyHEAT to develop this solar potential map that actually uses takes advantage of the Google Earth data. So it's very similar to something like Project Sunroof, and is using the same logarithms and data from that system in the US. And if you enter in your address, it shows you your home and then subsequently the opportunity and kind of what you might expect as the investment and the return on investment for installing solar on your home. So this is my home. You can see the person that we bought it from has incredible gardening skills by how beautiful the garden is back there. But you'll see that we have decent solar potential and there is still a good area. But we do live in an old neighborhood on a tree-lined street. So there's actually maybe better potential on my garage. And we're finding that a lot of Edmontonians are putting solar panels on their garage because that is another option that certainly is eligible. And then just briefly, you also may have heard about a federal announcement a few months back about a greener homes program that they are working on. But we did want to mention it because it's very relevant for actually probably it seems like both HERA and solar. So they've talked about up to 1 million free EnerGuide energy assessments and then up to $5,000 per home for 700,000 homes. So what we understand is more details should be available about this in the spring, but the announcement was very clear that it's retroactive to December 1st, 2020. So it's even more of a reason, I think, to consider renovations and the energy efficiency of your home right now, because you'd be hopefully able to stack. Ideally, we would have all of the details of this program available now, but we do know that they're coming soon, and is really a great, I think, boost for these renovation activities in Canada. And maybe we'll share the link because that's just an awful link, but maybe Karen, Heather, I can post that link in the question or something as well. And then the last thing I thought I'd share is you also may have heard about something called CEIP, or the Clean Energy Improvement Program. So this is a program that the City of Edmonton has been working on for some time. It is a financing tool for energy efficiency renovations and renewable installations on homes and buildings. So it's very similar to a PACE financing tool that is sort of a more common term used in a lot of American states and cities, for example. And it enables low cost, long-term funding for those kinds of upgrades on a home. So it pays for 100% of a project's cost, and then the repayment is through the property taxes over the lifetime of that, whatever the upgrades are in the home. So I think why this is very, it's considered very important and central to achieving the kinds of upgrades that are needed across cities, I guess across nations, is that really it changes the decision making in a home to encourage decisions that are over the lifetime of that home rather than over the length of time a person may own it. Because home ownership is becoming shorter and shorter. We see, I think the average is 5 or 6 years now. People are selling homes. So it's really hard to make the kinds of long-term energy efficiency or renewable decisions if home ownership is not quite as long. So this allows repayment and that financing to stick with that property, with the actual building that gets those benefits over the lifetime of those benefits. So, we are working on the bylaw for this right now. There's a province-wide organization that's going to be administering PACE in different municipalities that opt in to the program. And we do hope that it'll be available in August 2021. And that's everything for me.
Thank you so much, Lisa Dockman, for sharing your insights and your expertise with us. And thank you, participants, for joining us for today's Lunchbox session.